1b. Great Rift Valley. The Great Rift Valley is one of the most distinctive features of African topography. Formed where Earth's crust is being pulled apart by the action of convection currents beneath the surface, rift valleys are long, deep valleys bounded by parallel faults, or fractures, in Earth's crust. The Great Rift Valley system begins in Syria, in the Middle East, and extends southward, down the length of the Red Sea. It enters Africa at the Afar Depression on the coast of Eritrea and Djibouti, and winds some 5,600 kilometers 3,500 miles to the coast of southern Mozambique. In its middle section, it breaks into two major branches, the Eastern Rift Valley and the Western Rift Valley. The Rift Valley is flanked by towering escarpments of up to 1,000 meters 3,000 feet in southern Ethiopia, 1,500 meters 4,900 feet along the Eastern Rift in central Kenya, and 1,300 meters 4,300 feet in the northern part of the Western Rift, along the DRC's border with Uganda, Rwanda, and Burundi. The southern extremities of the rift system are much less spectacular in size and appearance. For more information, see the Faulting and Rift Valleys section of this article. Several major lakes, typically long and narrow, are located on the floors of the Western and Eastern Rift Valleys. The Western Rift contains Lake Albert, Lake Edward, and Lake Kivu to the north, Lake Tanganyika in the middle, and Lake Malawi, Lake Nyasa, to the south. The lakes of the Eastern Rift tend to be smaller and include Lake Naivasha, Lake Natron, and the southern part of Lake Turkana. 1c. Deserts. The Sahara is the world's largest desert. It stretches from the Atlantic Ocean to the Red Sea, and from the Mediterranean Sea and Atlas Mountains southward for 2,000 kilometers 1,000 miles until it merges imperceptibly into the semi-desert Sahel region. Most of the desert consists of extensive plains covered with loose gravel and boulders, called reg. The rest of the desert is made up of areas of shifting sand dunes, called erg, interspersed with stretches of bare, rocky areas called hamada. The Namib and Kalahari deserts of southern Africa are much smaller than the Sahara. The Namib Desert stretches along the Atlantic coast for 1,500 kilometers 930 miles from southern Angola along the entire length of Namibia, and into western South Africa. The nearby Kalahari Desert, in Botswana, Namibia, and South Africa, is a semi-arid region in the center of the Kalahari Basin. 1d. Coastline. Generally, Africa's coastline is very even, with few good natural harbors. The coastal plain is narrow around much of the continent, particularly in the south and east. Major escarpments run parallel to the coast in several areas. Most of the Red Sea and Indian Ocean coastline is fringed by coral reefs, which are an obstacle to ships. On the Atlantic coast, waters are generally too cold for coral development. Africa's best natural harbors are found in the many deep coastal inlets between Senegal and Liberia, especially at the mouths of rivers. Lagoon coasts, with a coastal barrier beach backed by lagoons, are common between Liberia and Nigeria. 2. Formation of Africa. Scientists use the theory of plate tectonics to explain the formation of Africa and the other continents. According to this theory, the crust of Earth's surface consists of a collection of 14 rigid plates floating on an underlying mantle. These plates are in constant motion, moving apart, colliding, and thrusting beneath one another. Africa sits at the center of the African plate, one of the largest of Earth's plates. For much of Earth's history, the land made up one vast supercontinent known as Pangaea. About 220 million years ago, tectonic activity broke Pangaea apart into the supercontinents of Gondwanaland and Laurasia. Gondwanaland subsequently broke apart as well. First Antarctica, Australia, Madagascar, and the Indian subcontinent broke away, followed by South America. Africa, at the core of Gondwanaland, assumed roughly its present-day shape about 15 million years ago when the formation of the Red Sea split off the Arabian Peninsula. 3. Geological structure. The geological structure of Africa is very complex, reflecting many stages and types of development over a period of 3.5 billion years. Most of the continent consists of rock dating from the Precambrian period, more than 570 million years ago. These rocks are either igneous rocks such as granite or metamorphic rocks such as schist, gneiss, and quartzite. These ancient rocks, along with some slightly younger sedimentary rocks such as sandstone and limestone, make up what is called the basement complex of the African continent. In much of the continent, younger deposits of igneous and sedimentary rock were laid down on top of the basement complex. The largest of the sedimentary deposits formed in northern and western Africa during the Paleozoic era, between 570 million and 240 million years ago. Later in the Paleozoic, sediments were deposited in parts of present-day South Africa. In the Mesozoic era, between 240 million and 65 million years ago, this area was also covered with igneous basalt from major lava flows. Sedimentary limestone was deposited during the Mesozoic on Africa's northern edge. More recent sedimentary deposits dating from the Cenozoic era, from 65 million years ago to the present, occupy the bottoms of the continent's large, shallow interior basins and some coastal areas. 4. Geological evolution. Africa contains 3 major cratons, or areas of basement complex rock that have been geologically stable for hundreds of millions of years. The Kalahari Craton is located in southern Africa, the Congo Craton is in Central Africa, and the Northwest African Craton, forming the core of West Africa, is centered in the Western Sahara. Areas between the cratons contain somewhat younger rocks. These areas have undergone more extensive and continuing geological change since the late Precambrian period, caused by processes such as faulting, volcanism, folding, and crustal displacement. A4a. Faulting and rift valleys. Faulting, meaning the cracking of the Earth's crust, continues to break apart the African continent. Faults occur between two parts of the crust that are moving slowly and sporadically in relation to each other, either moving away from each other or sliding up, down, or side to side. When two pieces of land are being pulled apart, numerous parallel faults develop between them as the edges cleave off and are displaced downward. The resulting formation is known as a rift valley, with a steadily lowering valley floor bounded by steep cliffs known as rift scarps. The Great Rift Valley system of East Africa traces sets of parallel faults in the African plate that run from the Afar Depression in Eritrea and Djibouti to southern Mozambique. Millions of years from now, as the Great Rift Valley continues to widen and deepen, East Africa will likely split off from the rest of the continent. The Great Rift Valley is not uniform, different segments are distinct in appearance and are affected by different geological activities. The triangular Afar Depression, also known as the Afar Triangle, a very low area fringed by rift scarps, is geologically unstable. The depression is widening and deepening by several centimeters per year, with accompanying volcanic activity and frequent earthquakes. In the part of the Western Rift where Lake Tanganyika is located, there has been a vertical displacement, the distance between corresponding rock strata in the land above the rift and in the lowering rift valley bottom below, of up to 6,000 meters 20,000 feet. Some parts of the rift system, for example, the northern part of the Western Rift, are associated with very extensive volcanic activity, while in other areas, such as the Lake Tanganyika sector, volcanic activity is absent. Rift systems occur elsewhere in Africa, most notably in the valley of the Benue and lower Niger rivers in Nigeria. Also in West Africa, volcanic activity and tectonic movement occurs along a major fault line that extends inland from the offshore island of Bioko through Cameroon Mountain to beyond Lake Chad. This line has been interpreted as the early stage of a rift system that could eventually result in the separation of West Africa. A4b. Volcanism. Volcanism has contributed significantly to the shaping of the African continent since ancient Precambrian times. Considerable volcanic activity accompanied the breakup of Gondwana, notably creating extensive lava deposits in southern Africa and covering the Ethiopian plateau with massive deposits of basalt. Elsewhere in Africa, volcanism is associated with hot spots, areas located directly above focused plumes of magma rising from the Earth's interior. The Tibesti and Ahagar mountain ranges of the Central Sahara, both volcanically active regions, sit over hot spots. Other hot spots lie under Cameroon Mountain, the Western Rift Valley, and several offshore locations such as Comoros and Réunion in the Indian Ocean and Ascension and St. Helena in the South Atlantic Ocean. The most spectacular products of volcanism are several major peaks associated with the Great Rift Valley system in East Africa. These now dormant peaks include Kilimanjaro, Mount Kenya, Mount Meru, and Mount Elgon. In contrast, Nyiragongo and Nyamulagira in the Virunga Mountains along the border between Rwanda and the DRC and Cameroon Mountain are active volcanoes. Africa's extensive lava plateaus, though less spectacular than the volcanic peaks, are nonetheless important to the continent's development. The weathering of these volcanic deposits has provided some of Africa's most productive soils. Rwanda and Burundi are examples of regions of volcanic origin that support very productive agriculture and high population densities. A4c. Folding. Differences in pressure in the Earth's crust cause it to buckle upwards, or fold. Folded mountains are less prominent in Africa than in other continents, a reflection of the geological stability of its basement complex rocks. The Atlas Mountains in northwestern Africa and the Cape Ranges including the Swartberg and Langberg mountain ranges in South Africa are the only examples of folded mountains on the continent. A4d. Crustal warping and uplift. Over the last 500 million years, Africa has experienced many sequences of surface warping. In this process, crustal pressure bends the Earth's surface without creating folds or faults. Down warping created the continent's major basins, while up warping produced upland regions such as the Guinea Highlands and Ethiopian Highlands. These uplands fringe the basins, and divide them from one another. For example, the Ahagar, Tibesti, Endi, and Mambila Mountains, together with the Jos Plateau, surround the Chad Basin. Much of the African continent lifted up after it separated from the other continents due to isostatic adjustment, the tendency for Earth's crust to seek gravitational equilibrium. This uplift took place over a prolonged period, and was especially significant in the south, where it gave rise to the great escarpment along the fringe of the continent. In East Africa, the tectonic processes that created the rift valleys simultaneously created upwarped areas and uplifted mountain ranges, the largest being the Ruwenzori Range along the Uganda-DRC border. A5. Weathering and erosion. The surface of Africa, like all continents, is affected by weathering and erosion. Weathering refers to the processes of physical disintegration and chemical decomposition of solid rock materials at or near the Earth's surface, while erosion refers to the removal of weathered rock and soil material by natural processes such as running water, glaciers, waves, and wind. The general flatness of much of the African landscape is the result of deep chemical weathering of bedrock, together with prolonged erosion that has smoothed the surface over many millions of years. A 5